In this video, we want to learn about rationalizing the denominator of an expression. It is usually useful to eliminate the radical in a denominator by multiplying numerator and denominator by an appropriate expression. This procedure is called rationalizing the denominator. Sometimes we also do same thing for numerator. Basically, we try to rationalize numerator also. But usually we try to rationalize the denominator because it helps to simplify expressions. But how we rationalize an expression? Let me show you some examples. During doing these examples, we will learn this procedure. This is the first example, 5 over radical 3. As you can see, we have a radical in the denominator, and we try to get rid of the radical. For doing this, we multiply numerator and denominator by radical 3. The reason that we multiply numerator and denominator by this is that by multiplying by this expression, which is 1, we do not want to change the value of the original expression. That's the reason we multiply numerator and denominator by an appropriate expression, which in this case is radical 3. But why this help us to get rid of the radical? Let's multiply numerator by numerator. Then we have 5 radical 3. And by multiplying denominator by denominator, we have radical 3 to the 2. We have radical 3 to the 2. Radical 3 to the 2 is 3, because 3 to the 2 is 9. Radical 9 is 3. So we have 5 radical 3 over 3. As you can see, by multiplying this expression by radical 3 over radical 3, now we have an answer that in the denominator we don't have anymore the radical. Look at the next example. We have 3 over radical 6. We want to get rid of radical 6. We want to get rid of the radical in the denominator. For that, we multiply numerator and denominator by radical 6. Then we have 3 radical 6 in numerator. Radical 6 times radical 6 is radical 6 to the power of 2. The power 2 with the index of the radical cancels, because these two are the same, so radical completely goes away, and then we have 6 only in the denominator. So we have 3 radical 6 over 6. If you pay attention, you can simplify this answer a little more, because 3 and 6 have a common factor, that is 3. 6 is 3 times 2. So if we simplify this answer, we can write the answer in the form of radical 6 over 2. Again, this is because 6 is 3 times 2. If we cancel 3 with 3, we have radical 6 divided by 2. And this is the final answer for this question. Please pay attention. When you multiply radical 6 by radical 6, the answer is radical 6 to the 2. You don't need to calculate this. Sometimes this number is a large number, and raising to the power 2 would be maybe hard. Just notice that when the power and the index of the radical are the same, you can cancel the radical and the power. So, in general, attention, in general, when we have radical a times radical a, the answer is a. The reason is that radical a times radical a is radical a to the 2. The power with radical cancels, and the answer is a. So, you don't need to raise the number to the power of 2. Now look at these examples. 1 over radical a and radical 2 over 3. For the first one, we have to multiply numerator and denominator by radical a over radical a. In numerator, we have 1 times radical a, which is radical a. In denominator, radical a times radical a again is radical a to the 2. The power 2 with radical cancels. In denominator, we have radical a all over a. Attention, gradually it's better to do not write this, and radical a times radical a, right away write a. You don't need to write this middle step here. Look at the next example. Radical 2 over 3. As you can see, we have a big radical, and inside the radical we have 2 over 3. First, it's a good idea to write this in the form of radical 2 over radical 3. We separate this radical for numerator and denominator. This is one of the properties of radicals. Remember, radical a over b is radical a over radical b. The reason that we do this is that we want to have a denominator separated from numerator. Now we want to rationalize this. How we can rationalize this? We multiply numerator and denominator by radical 3. In numerator, radical 2 times radical 3 is radical 6. Radical 3 times radical 3 is 3. Remember, radical a times radical a is always a. So the answer is radical 6 divided by 3. Now look at these examples. 1 over radical 5x, radical a over 2b. For the first one, we have to multiply numerator and denominator by radical 5x. And again, let me mention this. The reason that we multiply numerator and denominator by this expression is that we want to multiply the original expression and we don't want to change the value of this. We want to have same value but in another form. So that's the reason we multiply numerator and denominator by this expression. Because now, what is the value of this fraction here? 1. So multiplying anything by 1 doesn't change the value of the expression. That's the reason always we multiply numerator and denominator at the same time. Now what is the answer? The numerator is radical 5x. For the bottom, radical 5x times radical 5x is only 5x. The radical cancels. Look at the next one. I highly recommend you pause the video here. Try this question by yourself, then continue watching the video. We can write this in the form of radical a over radical 2b times by radical 2b over radical 2b. So first, we separate the radical. Now we have a fraction. This is the numerator of the fraction. This is the denominator of the fraction. Now we want to rationalize the denominator. For numerator, what is the answer? If we multiply radical a by radical 2b, the answer is radical a times 2b. So a times 2b. But this is not good to write radical a times 2b. Instead of writing a times 2b, we can write this simply as 2ab. Move the 2 here, and then the answer is 2ab. The order of multiplication of the expressions doesn't matter. So it's better writing this in this form. So when we multiply numerator by numerator, we have radical 2ab all over radical 2b times radical 2b is 2b. The radical cancels. Now look at these examples. 2 over cube root of 5. Here the story is a little different. We don't have a square root. We have cube root. Please pay attention. When we have cube root of 5, what power we need for 5 so that we can cancel the power with the index? Of course, the power should be 3. But here the power is 1. So what power of 5 we need to add to this power so that then we have cube root 5 to the 2, because 5 to the 1 times by 5 to the 2 would be 5 to the 3. Then if we have cube root on top of that, this power with this index cancels and we can get rid of the radical. So let's back to our question. Here, if we multiply numerator and denominator by cube root of 5, it's not enough, because if we do so, then in denominator we have cube root of 5 to the 2. But we need power 3 here, because 5 to the 1 times 5 to the 1 is 5 to the 2. But we need 5 to the 3 here. So what power I have to put here for 5? 2. So we multiply numerator and denominator by 5 to the 2. Cube root of 5 to the 2 over cube root of 5 to the 2. Now when we multiply denominator by denominator, denominator would be cube root of 5 to the 3. And for numerator, just multiply the number 2 by the radical. Then we have in numerator 2 cube root of 5 to the 2, which you can write at 25 if you want. Look at the denominator. The power and the radical index are the same, so the radical and the power cancel each other. So in denominator we have only 5. And in numerator we have 2 cube root of 25. So now this expression is rationalized, which means that now we don't have any radical in the denominator. Look at the next example. 7th root of 1 over a to the 2. Here, it's a good idea to first separate the 7th root for numerator over denominator. 7th root of 1 is 1. Now in denominator we have 7th root of a to the 2. Now we have to multiply numerator and denominator by a to the power of, you have to put a power here, that when we add that power to 2, it would be 7. So what power of a we have to put for a? 5. So we multiply numerator and denominator by 7th root of a to the 5. Numerator is only this, but for denominator, when we multiply these two radicals by each other, then we have 7th root of a to the 7. The power and radical cancels, so final answer is 7th root of a to the 5 all over a. So attention, when we multiply this radical by this radical, this power adds to this power, then we have a to the 7. The power 7 and 7th root cancels, and then we have a. Gradually, it's better for you to be able to multiply these two by each other and immediately skip this middle step and jump to here. Let me tell you the rule for this. Please pay attention to here. Whenever we have, let's say, 5th root of a to the 3, when we multiply this by 5th root of a to the 2, what is the answer? Yes, the answer is 5th root of a to the 5, but skip this middle step. The answer of this is a, because when we add this to this, the power is 5. The power 5 and the radical cancels, so simply erase the radical and the power all together. The answer is only a. But don't worry for this. Gradually, when you do more examples, you can do this automatically by yourself. Now look at these examples. 1 over 5th root of ab to the 4. In the radical denominator, we have two variables, a and b. The power of a is 1, the power of b is 4. So it's clear that we have to multiply by 5th root of something. But what is that expression? What expression we have to put here? Attention, the power of a here is 1, but we need power 5 for a. The power of a already is 1. So what power I have to put here? A to the 4. Because 4 plus 1 is 5. What about b? The power of b already is 4, but we need power 5. So we need to multiply by b to the 1. So because b to the 1 times b to the 4 would be b to the 5. So we multiply numerator and denominator by a for b. Don't forget to write b for numerator. Numerator is simply 5th root of a for b. What about denominator? When we multiply denominator, we have 5th root of a times a4 is a5. b4 times b is b5. The power 5 and the 5th root cancel each other. So in denominator we have ab. Attention please. This power with these cancels, so a goes here. The power 5 and the 5th root cancels and we have b. Please pay attention. This 5th root is for this and for this. So when we cancel this with the 5th root, it doesn't mean that you can move the b to the 5 to the outside. No. This root here is for both of these. So for each of these, you have to cancel the power with the radical. And this is the answer of this question. Look at the next one. A over 6th root of b to the 2. It should be clear for you that we have to multiply by 6th root of b to the 4. Because the power already is 2, but we need power 6. So if we multiply by b to the 4, then 4 plus 2 would be 6. The numerator is simply a 6th root of b to the 4. What about the denominator? When we multiply b2 by b4, it's b to the 6. So In numerator, we have simply a 6 root of b to the 4. But what about denominator? Maybe like other examples that we have seen so far, you think that, okay, this power with this index cancels. Yes, you are right. And so the answer is b. But there is something here that you have to notice. You have to put absolute for b here. The reason that you have to put absolute for b here is that whenever we have a radical with even index like 6 here or 4 or 2, whenever, let's say we have radical a to the 2, what is the answer of this? If you are thinking the answer is always a, no, you are right. The answer is absolute of a. So when you cancel this power with this index, the answer is absolute of a. And the reason for that is that maybe this variable a, attention, a is unknown to you. So maybe a is negative, but we know that the answer of a radical with even index, like this example, is always positive. So if you forget to put absolute here, maybe a is negative, then the answer of a radical is negative, which makes no sense. The radical answer of any radical with even index is always positive. So you have to put absolute here. Here also, the index of the radical and this power are the same, so you can cancel them. But maybe b is negative, and because we don't know the value of b, we have to put absolute for b here. This is the reason that we have to put absolute in this example. But when we have fifth root of something, we don't need, because for the fifth root or third root, the answer can be positive or negative. So we don't need to put any absolute for this. But this is the topic of not this video, but I mentioned this example here because it's important that to put absolute in your answer here. Now look at these examples. This is a new type of rationalizing denominator. The difference is that here in the denominator we don't have a single term like the previous examples. We have two terms. Why we say two terms here? Because we have something plus or minus another thing. If you look at the previous examples that we have done so far, we had only a single term. When you have a plus minus between some expressions, they are different terms. So this is completely different story. But how we rationalize these type of questions? Whenever we have a radical, a square root especially, in denominator, plus minus something, the idea, the method that we try to get rid of denominator, the radical in denominator, is remembering this identity. Let me remind you something. If you remember, we had this identity, a minus b times a plus b is a to the 2 minus b to the 2. Probably you are familiar with this identity. A minus b times a plus b is a to the 2 minus b to the 2. A plus b is conjugate of a minus b, and a minus b is the conjugate of a plus b. So whenever we have two terms added or subtracted from each other, the conjugate of this expression, for example, what is the conjugate of 2 plus radical 3? 2 minus radical 3. What is the conjugate of radical 5 minus radical 3? Its conjugate is radical 5 plus radical 3. So whenever we say in math conjugate of an expression, conjugate means same expression but with opposite sign between the terms. So this is the story of the conjugate. But what is the relation between this identity and rationalizing the denominator? Please pay attention. Let's say we have radical 5 minus radical 3. Like here. If we multiply this expression by its conjugate, which is radical 5 plus radical 3, what happens? Remember this identity. Whenever we have a minus b times a plus b, the answer is a to the 2 minus b to the 2. So here we have a minus b. We have multiplied this by its conjugate, which is radical 5 plus radical 3. So here we have, please pay attention, here we have a minus b times a plus b. What is the answer of this? Based on this identity, the answer is a to the 2, which is radical 5 to the 2, minus b to the 2, radical 3 to the 2. The power 2 over 2. The power 2 with radical cancels. The power 2 and radical cancels. That's the reason I mentioned this identity here. Now let's do this question to learn the method for rationalizing this type of expressions. For the first example, what we have to multiply numerator and denominator by? We have to multiply numerator and denominator by 2 minus radical 3. The reason is that, if you pay attention, if this is a plus b, its conjugate is a minus b. Now what is the answer? 1 times by this is the same thing, 2 minus radical 3. What about denominator? Please pay attention. When you want to multiply this by this, never think to distributing these two by each other. You don't need to multiply term by term, 2 times 2, 2 times radical 3 times 2, radical 3 times radical 3. No, don't waste your time that way. Please pay attention. I mentioned something, a plus b times a minus b. The answer is always a to the 2 minus b to the 2. And here exactly we have a plus b times a minus b. The answer is a to the 2. Raise this to the 2 minus the other term to the 2. So what is the answer of this here? The answer is a to the 2. What is a? A is 2. So the answer in the denominator is 2 to the 2 minus radical 3 to the 2. In numerator we have 2 minus radical 3. In denominator 2 to the 2 is 4. Radical 3 to the 2 is 3 because the power 2 with radical cancels. So in denominator we have 4 minus 3. But 4 minus 3 is 1. So denominator is only 1. So basically this is equal to 2 minus radical 3 because anything divided by 2 is the same expression. Look at the next example. We have radical 2 divided by radical 5 minus radical 3. What we have to multiply numerator and denominator by to get rid of these radicals in the denominator? We have to multiply by the conjugate. What is the conjugate of radical 5 minus radical 3? The conjugate is, yes, radical 5 plus radical 3. For numerator, multiply radical 2 in each bracket. Radical 2 times radical 5 is radical 10. Radical 2 times radical 3 is radical 6. What about the denominator? Again, use the shortcut. A minus b times a plus b is a to the 2. So the denominator is radical 5 to the 2 minus radical 3 to the 2. Numerator is radical 10 plus radical 6. But denominator is radical 5 to the 2 is 5. Radical 3 to the 2 is 3. 5 minus 3 is 2. And this is the final answer for this question. Radical 10 plus radical 6 divided by 2. And as you can see, we don't have any radical in the denominator. So we rationalized the denominator, which means that eliminate the radical in the denominator of the expression. Now look at these examples. 1 over radical a minus radical b. We want to rationalize this. So what we have to multiply this by? We multiply by radical a plus radical b over radical a plus radical b. The numerator is simply radical a plus radical b because 1 times by anything is the same thing. But what about the denominator? Radical a minus radical b times by radical a plus radical b is radical a to the 2 minus radical b to the 2. Gradually you have to skip this middle step. And you have to write this right away in the form of a minus b. This is the final answer of this question. Look at the next question. We have to multiply it by 3 radical 2 plus radical 10 over 3 radical 2 plus radical 10. Numerator is again 3 radical 2 plus radical 10. What about the denominator? The denominator would be 3 radical 2 to the power of 2 minus radical 10 to the 2. Numerator is again 3 radical 2 plus radical 10. What about denominator? Attention, this power is for all of this. So you have to raise 3 to the 2 and radical 2 to the 2. 3 to the 2 is 9. Radical 2 to the 2 is 2. So 3 radical 2 to the power of 2 is basically 18. Let me explain this again. 3 radical 2 to the 2 is like 3 to the 2 times radical 2 to the 2. This power and this radical cancel. 9 times 2 is 18. So denominator is 18 minus 10. 18 minus 10. 18 minus 10 is 8. So the answer is 3 radical 2 plus radical 10. So we rationalized this expression and this is the answer. Now look at this example. Rationalize numerator. It happens that we need in an expression to rationalize numerator, which means that eliminate radical in the numerator. Especially we need this technique in the calculus. When we try to find derivative of functions or finding limit of functions, we need this technique. So it happens that we want to rationalize numerator. The technique is the same. We multiply numerator and denominator, but this time by the conjugate of the numerator, because the idea is to get rid of the radical in numerator. So we multiply numerator and denominator by the conjugate of the numerator, because the radical is in the numerator, as you can see. But the technique is the same, so it should be easy. To rationalize this, we multiply numerator and the denominator by this. The conjugate of numerator. What is the conjugate of a minus b? A plus b. By doing this, what happens? And this equals to, when we multiply denominator by denominator, we have in the denominator h times radical x plus h plus radical x. You don't need to multiply h in the bracket, leave it outside. And for numerator, remember the identity a minus b times a plus b is a to the 2 minus b to the 2. So numerator would be radical x plus h all to the 2 minus radical x to the 2. But we know that the power 2 with radical cancels. So what is the final answer for numerator? If we cancel this power 2 with radical, here we have x plus h. And for the other radical, we have just x. And if we subtract x from x, x minus x cancels, so numerator only would be h. And now if you pay attention, h from numerator with h from denominator cancels, so this goes with this. So what we have as the final answer for this question, we have 1 over radical x plus h plus radical x. As you can see here, we rationalize numerator. Numerator has no radical, but of course the denominator has radicals. Look at the next example. Here again we want to rationalize numerator. So we multiply numerator and denominator by radical 1 plus x plus radical 1 minus x all over radical 1 plus x plus radical 1 minus x. For denominator again, don't touch anything, just leave the 2x outside and the radical here. What about numerator? When we multiply numerator by numerator, the radicals cancels. A to the 2 minus b to the 2. Remember that? The radical goes away. So what remains in numerator? We have 1 plus x minus 1 minus x. The reason that here I prefer to put a bracket, especially for this part. This part is optional, but for this, because we have a negative between 1 plus x and 1 minus x. This negative is for all of this. This is the better way for writing numerator. Now simplify numerator. If you pay attention, the numerator here, 1 plus x minus 1 plus x. Numerator is 1 plus x minus 1 plus x. 1 with 1 cancels. 1 minus 1 is 0. X plus x is 2x. So basically this is 2x. Now this 2x with this 2x cancels. So the final answer for this question is 1 over radical 1 plus x plus radical 1 minus x. So this expression is rationalized, but not in the normal way. We have rationalized numerator. And again, let me mention this. We rationalize numerator in the calculus for some good reasons that you will later, when you take calculus course, you will see what is the reason that we rationalize numerator. And this is the reason I included these examples here, to prepare you for the calculus. I hope by watching this video you have learned enough for rationalizing expressions. Again, what is rationalizing an expression? Eliminating radical, sometimes in numerator, sometimes in denominator. I hope this video was helpful for you. If you like this video, please subscribe in my channel and see you in the next videos.